There are 4 students, no? Hello. Hello. Hello, can you hear me?
Yes, sir, you're audible.
Okay. So if anybody has any questions, you can just unmute and ask. Mukul, you have any question? Rajat Kumar, Jayavelu. Devendra Rao, Satyam. Anybody, if you have any questions, please ask.
Sir, there is some questions. Okay.
Yes. Yes, Develu.
And there is a hydro plant in the Kadambar area. Okay. And so there is a crack in the wall where the spiral casing there. The spiral casing was enclosed by a concrete. There will be horizontal crack there. Okay. The project was commissioned during 1971. Okay.
Can you start off again? It was not clear. What is that project it is?
It is a hydro plant.
Okay. Power plant.
A power plant, hydro generation power plant.
Yeah. Okay.
There is a spiral casing there. There is a Pelton wheel turbine. The water will be injected through the nozzle to the turbine.
Yes.
So there is a inside spiral casing was enclosed by a concrete chamber. Okay, there is a horizontal crack in the concrete chamber.
Okay.
The project was considered during 1971.
Okay.
For ascertain the crack development, they placed a small piece of glass. Okay. Now the glass was broken.
Okay.
And now today, this year, I see what action to be next taken to ascertain the further crack development? Or
See,
what?
Yeah, it's very difficult to comment on this without seeing a photograph or get some more details about the issue. Okay.
Okay, sir.
So you can probably email or even WhatsApp me the some photos or something so that I get a better idea of what is the crack and some idea. Then only we can say something.
Okay, sir. Okay.
You can take my number.
Okay.
900
322
8158.
Okay, sir. Thank you.
Yeah, and you can message me or email me. That's also fine.
Okay, sir.
Yeah, either way, because without knowing more details about the situation, we cannot comment. Yeah.
Okay, sir.
Yeah. Any other questions? Anybody else? Yeah, there is this question. Nila, you put the question, is it? Is it from somebody?
Yes, sir, it's from the discussion forum. We have given the answer, but there is not a right answer for that. So if you give some solution for them, it will be.
What is the answer you gave?
So we gave around 500 to 600 meters we can expect. It's from a research article. So we gave our answer from that article.
Yeah. So usually, people say 500, and some codes you will also see 1 kilometer. The effect definitely reduces as you move away from the sea. But mostly you can say up to 500 meters or maximum 1 meter, not beyond that. Airborne chloride effect will be much less beyond that. But again, one has to, if you're thinking about what type of structure you have to see, if you're talking about some, 100-year-long life structure, then you might want to think a little bit more deeper, how the seashore will also change. But still, I think you can ballpark number, you can say 500 meter is a good number. So up to 500 meter, take it very carefully. Beyond that, there is, I think, a Japanese code where the the surface chloride condition, etc., is very clearly mentioned for various distance from the seashore. So people can look at that. Any other question? See, what I mean to say is, it is not that after 1 kilometer away from the seashore, you don't have any chloride related problem. You will have chloride related problem, but then you have to see what is the life of the structure, and for that life, will there be any problem? That's how you want to really think about it. If you're talking about some 10-year life, 20-year life, maybe you don't have to worry about if it is 2-3 kilometers away from the seashore. But if you're talking about longer service life, definitely one has to think about it. Any other question? Did I answer this correctly, Neela? Sufficient?
Yes, sir.
Okay.
We were not able to address any code in the
there is a Japanese code. There
okay,
is a
sir.
Japanese code. I can send it as an email or something, and then you can post it.
Sure, sir.
Yeah. Okay. Any other question? Question number 4 from assignment 3. Can you tell what is the question, Nikhil? I can't remember.
Sir, it is about plastic shrinkage and drying shrinkage.
Yeah, tell me very clearly what is the question, and then I'll answer.
There are two cases, sir, that are given. Plain concrete slab placed directly on soil. And the second case is plain concrete slab placed on well-leveled finished soil with a plastic membrane in between. So the question is, about plastic shrinkage and drying shrinkage, as to in which cases will it occur depending on the time period. Will it occur within a few weeks or after a few months?
Yeah, and plastic shrinkage will, if you're talking about plastic shrinkage, that is when the concrete is still in plastic stage. So first few hours, or that's what we talk about when when we talk about plastic shrinkage. Anything beyond that, we consider it as drying shrinkage. If it is due to the moisture loss.
Okay, sir.
Okay.
Okay.
Any other question?
Sir, what is the mechanism in the providing a polythene membrane in between the slab and the soil grade?
Yeah, one thing is, if you don't want the moisture from the concrete to be lost or to be absorbed by the soil below. That is one thing. So if you put a plastic sheet, it won't. Another thing is, it makes it disjoint two systems. So when it comes to flexural behavior and all that, it will have a different mechanism when we put a plastic membrane below. or any movement, this is what main thing is the way in which the beam behaves will be, the slab behaves will be different when you have a membrane in between and when you do not.
Sir, if plastic shrinkages occur, okay, then only the drying shrinkage will occur or not?
No, not like that. Plastic shrinkage it's not that one is dependent on the other. Okay, plastic shrinkage, for example, if you have, let's say, very cement rich concrete, or sorry, a lot of water, or whatever be the condition, if you have significant bleeding happening, then there is a significant bleeding, and if you do not have replenishment of that bleed water, then you can have plastic shrinkage. It's just a matter of time when it happens. Okay, so usually concrete bleeds, right? Usually, if you have bleed water and the top surface of the concrete will, the moisture from the top surface of the concrete will be lost in the beginning. And if that is not replenished by the bleed water which is coming from the bottom of the concrete, then you can have, shrinkage cracks, because then there will be a differential, forces will be there, and then at the top surface you will have cracking, and that's what essentially we call as plastic shrinkage, and this happens in the initial hours. When you talk about drying shrinkage, this happens later time, after the concrete really hardens, and then you have further moisture loss, and that's when we call it as drying shrinkage.
Okay, so thank you.
So we actually add, there are plastic fibers which we add in concrete, and it has been found that when you add plastic fibers, the plastic shrinkage can be controlled, because it doesn't allow the opening of the crack. I mean, that shrinkage forces, it will resist, but because it's a very small force as compared to, plastic fibers are good enough, good for controlling plastic shrinkage cracks. Even though both plastics have different meaning. Any other question? I think I explained this plastic shrinkage cracking in, when I talked about plastic shrinkage cracking, we discussed the silica fume concrete, right? Where a lot of fine materials are present. And if you look in those slides, it will be clear what I told you, where the moisture from the top surface will be evaporating. And because there is a lot of fine materials in the concrete, or silica fume materials are very fine, that will actually clog the pathways from the bottom of the concrete to the top, and that will stop the bleeding of water from lower level to upper layers. And because it stops the bleeding of the water or rising of the water, it eventually leads to cracking at the top surface and no cracking at the bottom level. And this is a very good example of plastic shrinkage cracking. And this happens in the first very few hours. So what we do is, when you have concretes like that with the silica fume, you definitely you have to prevent the moisture loss from the very beginning. So as soon as concrete is placed, it's better to cover the concrete so that there is no moisture loss from the top layer, because bleeding is very less in such case. Any other questions? If no questions, then we can close the session. If you have any questions, please ask. You can type also, type in the chat box if you cannot speak now. Okay, then I think we'll close the session. We will have our next session on March 21st, same time, same day, same time, same date, same time next month. Okay. Thank you. Satyam, you have any question or anybody, people who didn't ask anything? If you have any questions, just ask right away.
In the Google form, general question was asked during the mixing or during the concrete preparation. Do we consider the chloride?
Okay. Can you speak there so that others can also hear?
Yeah. So during that, can we consider the chloride content of water? So this is general question asked during the preparation of concrete. Do we consider the chloride contents of water?
Actually, the question is, do we consider chloride content of water while preparing for a new concrete, correct? Yeah, ideally we should consider, but unfortunately people do not check this thing, and that is why you are seeing, you know, there are a couple of news articles which came just very recently in New Delhi. In New Delhi, like, you know, there was a slab failure in one of the buildings, and we know that there are a lot of buildings like this where they have used untreated water for construction, and it has significant amount of chlorides. Actually, in IS 456, there is a limit for chloride content in fresh concrete is given, but unfortunately, people do not check this. So this is something which is very, very important if you're thinking about durability of structures, that one should make it, 0.6 kilogram per cubic meter or some, I forgot the number exactly, but that one can check the IS 456 on the chloride limits, in concrete. And this must be enforced, I think, even when after seeing these failures of structures in 4 or 5 years, I think it is high time that we should enforce this. Along with the compressive strength of concrete, we should also test the amount of, see, the thing is, compressive strength of concrete is for the mechanical performance of the concrete. We need to bring in some, testing for durability aspects. Okay. So it's very important to consider this thing. I think this could be one very good thing, which is limit on the chloride content and ensure it. It's there on the code, but nobody is practicing. So that's something wrong, which we are doing. Any other question? Okay, then we'll see next time. Thank you. Can I close? Okay, Jayvelu, then you can send me some photographs, and then we will communicate through WhatsApp. Okay.
Okay, sir. Okay, sir. Thank you, sir.
Okay. Okay. We'll actually see if we can add. There is actually a group for this NPTEL course, WhatsApp group. We will see if we can add the current students, because this is third or fourth time I'm offering this course. So we have a larger group called, so I will send an invite and add you all into this WhatsApp group.
Okay, sir.
Okay.
Okay, sir.
Thank you. Bye.
Thank you, sir.